Hello pre-calculus students, and welcome to a video on an example using the sum and difference formulas for trig. This is a video example of using the formulas backwards. So usually we use the formulas forward, this time we use them backward. So if you look at this first example, we're looking for the exact value of this mess right here. And notice that 20 degrees and 80 degrees, they're both not numbers that are on the unit circle. But also notice that this does follow one of the patterns of the sum and difference formula. So I wrote the four patterns to the right, and all you have to do is take a look at it and figure out which one is which. So I'm going to pause. You guys are going to have to pause the video and think about it for a second. Okay, so this is sine, cosine, minus cosine, sine. So first of all, it's a minus, so it's got to be this one or this one. And sine, cosine, minus cosine, sine, it's going to be this one. So that corresponds with the identity sine, cosine, minus cosine, sine right here. So that's going to be the sine of alpha minus beta. Okay, so what we actually are looking at here is the sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. Oops, that's a beta. All right, so you can see from this that alpha is 20, beta is 80. Okay, so let's put that in here. Now let's put that into the left side. That's what I mean by working backwards. So what we're really looking at here, and let me just write this down. So alpha is 20 and beta is 80. So we're going to put these in. So we have the sine of 20 degrees, these are degrees, minus 80 degrees. All we're really looking at is the sine of negative 60 degrees. Now, even though the original problem had a bunch of angles that weren't on the unit circle, now we've got an angle that is on the unit circle. At least it's coterminal with something that is. So if we look at the unit circle, negative 60 is right here, same place, coterminal with 300. We're looking at the sine, so there's the answer right there, negative rad 3 over 2. And that's all there is to it. Okay, let's look at another example. Okay, so this one is a tangent. And again, if you look at the numbers, these are in radians, but if you look at 2 pi over 9 and pi over 18, those are not numbers that are on the unit circle. But this will follow one of the two tangent sum difference formulas. So just pause the video, take a look, see if you can figure out whether it's A or B. And as you can see, one of them is negative in the numerator, positive in the denominator, so that has to be this one. And so if we look at the identities, the one that's negative in the numerator, positive in the denominator is subtraction, tangent of alpha minus beta. So tangent of alpha minus beta is equal to the tangent of alpha minus the tangent of beta over 1 plus tangent of alpha times the tangent of beta. And from here, hopefully you can see that alpha must be 2 pi over 9 and beta must be pi over 18. Alpha is 2 pi over 9, beta is 1 pi over 18. So what we're really looking at here is just the tangent of alpha minus beta, or 2 pi over 9 minus pi over 18. And you could convert these to degrees, but I would rather just subtract the fractions here. I have to get a common denominator. So 2 pi over 9 times 2 over 2 will give me 4 pi over 18, and I'm subtracting 1 pi over 18. Just gave away the answer. Subtracting 1 pi over 18, and I get 3 pi over 18, which is pi over 6. So we're really just looking for the tangent of pi over 6, which is on the unit circle. So we go back to our unit circle, tangent of pi over 6, right there, it's just rad 3 over 3, and that's it. Okay, hope you found this video helpful.